You've also said it's to produce 1 million robots, I think by 2030. That's what I had you on the record as saying.
I think that's a reasonable target.
Tesla just finished a chip that could change everything. Not for their cars, for their robots. And the decision to put it in the robot first tells you exactly where Tesla thinks the real money is going to come from. The chip that changes everything, here's what just happened. Elon Musk finished development on a chip called AI-5, in a package small enough to fit inside a robot's chest, running on around 250 watts of power. Think about that for a second. $30,000 processing power. Inside a robot, using about as much electricity as a few light bulbs. And here's the part that really got people talking. Tesla could have put this chip in their cars first. That would have been the safe move, the obvious move. Instead, they skipped the cars entirely and went straight to Optimus Gen 3. The robot got the brain upgrade first. That's not an accident. That's a very deliberate statement about where Tesla thinks the future is heading. And once you understand why, the whole story clicks into place. Before we get into what AI-5 actually changes, you need to understand why humanoid robots have been so difficult to build properly. Because this isn't a problem of imagination. Engineers have known what they wanted to build for decades. The problem is execution. A robot working alongside people doesn't just need to walk. It needs to see what's in front of it, hear what's being said, understand what's being asked, keep itself balanced, figure out how fragile the object in its hand is, decide how tight its grip should be, predict where the person walking toward it is going to step next, and do all of that at the same time. Continuously, without stopping. Half a second too slow and it looks broken. Wrong amount of force and it drops the cup. Wrong reaction when someone walks by unexpectedly and suddenly it's a safety problem. That's the gap that's been killing this industry. Not the vision, the execution. And that's exactly the gap AI-5 is trying to close. What AI-5 actually does inside the robot, here's the clearest way to understand this. Self-driving cars already have to process enormous amounts of information at once. Road markings, other vehicles, pedestrians, traffic lights, weather, speed, all simultaneously. In real time. Humanoid robots have to do all of that. Plus something even harder. They have to physically touch the world. A car avoids a problem by steering around it. A robot has to pick the thing up, hold it correctly, carry it safely, and put it down in the right place. Visual intelligence plus physical intelligence running at the same time. That's a massive computing demand. And until now, a lot of that processing had to happen in the cloud. The robot would collect data, send it off to a server somewhere, wait for instructions, then act. That delay, even if it's just a second or two, is a real problem when you're working next to a human being. AI-5 moves all of that processing inside the robot itself. No cloud, no waiting. Local decisions made instantly, like a reflex. And that difference between waiting for an answer and just knowing the answer is the difference between a robot that feels clumsy and one that feels genuinely useful. The factory strategy Tesla is reportedly deploying Optimus Gen 3 inside its own factories before selling it to anyone else. Fremont and Giga Texas first. And this is actually a genius move when you think about it. Factories are controlled environments. The pathways are fixed. The tasks repeat. The components stay in the same locations. Everything is predictable. That makes a factory the perfect place to start. Not because it's easy, but because every single mistake the robot makes becomes data. The robot stumbles on a task, engineers see it, they analyze what went wrong, they push a software update, and the whole fleet gets smarter overnight. Tesla did this exact thing with full self-driving. They didn't sit in a lab and try to manually code every possible scenario a car might encounter. They put cars on real roads, collected real data, trained on it, updated the software, and repeated that loop over and over. Millions of miles of learning. Now they're trying to do the same thing with robots. Except instead of learning how to drive, the robot is learning how to work. And physical labor is a much bigger market than transportation. The Fremont signal here's a detail that most people glossed over. Tesla reportedly just built the final Model S and Model X at the Fremont factory. Two of the most iconic cars they ever made. And now that factory space is reportedly being redirected toward the Optimus program. Let that land for a moment. The Model S was the car that proved electric vehicles could actually be desirable. The Model X was one of their most ambitious engineering statements. Tesla is taking the floor space that made those cars and pointing it at robots instead. That's not a small shift. That's Tesla saying out loud that they believe their biggest growth opportunity going forward isn't cars. It's physical automation. And when a company backs that belief with actual factory space, you start paying attention differently. What the robot actually needs to do here is where people get confused about what success looks like for Optimus. It doesn't need to cook your meals, clean your house, or replace every job overnight. That's not the target. Not yet. The target is much more practical. Move components inside a factory. Transport items from one point to another. Help with basic inspections. Serve drinks in a controlled environment. Deliver food at the Tesla diner. Help at supercharger stations. None of that sounds glamorous. But economically, it matters enormously. A robot that works 7 to 8 hours a day, repeats tasks consistently, and reduces the pressure on human workers is something businesses will line up to pay for. That's real economic value. And once the competition shifts from which robot looks most impressive in a demo video to which robot generates the most real-world value, Tesla becomes a very different kind of threat to the rest of the industry. The hands matter a lot here, too. Optimus Gen 3 has 22 degrees of freedom in its hands. That means it can hold a glass without cracking it, carry a full tray without spilling, and place objects with precision. And do all of that thousands of times in a row. Because in a real working environment, doing something once is easy. Doing it 10,000 times without failing is the actual challenge. That's what separates a demo robot from a robot you can actually deploy. Why Tesla is different from every other competitor Boston Dynamics makes incredible robots. Figure AI is moving fast. Unitree has a serious cost advantage. But none of them have what Tesla has. Billions of miles of real-world visual data from self-driving cars. Their own chip, their own software, their own batteries, their own manufacturing infrastructure, and their own factories where they can test the robot in actual operating conditions before it ever reaches a customer. Most robotics companies have to stitch together components from different suppliers with different standards and different development timelines. Tesla designs as much as possible in-house. The chip, the software, the batteries, the motors, the hands. All designed around each other. All optimized for the same goal. That's called vertical integration, and it's the exact playbook that let Tesla eventually manufacture cars at a cost that shocked the entire automotive industry. They're running the same play again. Just with robots this time. The feedback loop is the real product. Here's the thing most people miss about what Tesla is actually building. The robot isn't the product. The feedback loop is the product. First 1,000 robots go into Tesla factories. They make mistakes. Tesla learns from every single one. Software updates go out across the whole fleet. Next 10,000 robots go into multiple facilities. Data gets richer. Robots get smarter. Scale it to hundreds of thousands, and each robot stops just being a labor unit. It becomes a mobile sensor, constantly feeding data back into the system. Every robot that ships makes every other robot better. That compounding effect is what made full self-driving improve so dramatically over time. And it's the same engine Tesla is building for Optimus. The real question AI5 isn't just a chip upgrade. It's the key that unlocks the whole strategy. Better processing means the robot handles more complex situations. Better energy efficiency means it works longer on a single charge. Faster local decisions means it's safer around people. And by building their own chip, Tesla doesn't have to wait for Nvidia or Qualcomm or anyone else to decide what's possible. They control the roadmap. They control the timeline. They control the brain. That's the real shift happening here. Not just a robot that got a hardware upgrade. a company that decided it wants to own every critical piece of the system it's building. And if the history of Tesla teaches you anything, it's that when they decide to own something, they tend to get very good at it very fast. The robotics industry just got a lot more interesting.